So let's expand our example a little bit. Instead of reading a single value from the screen or from the user, we want to read 10 integer values, input it one by one, and then output their sum. If I do this in Python, I will have a very simple for loop saying that I have I in the range of 10, which means 0 to 9, and then I will ask the user to input these numbers inside the for loop. Every time I would kind of print the screen saying please input an integer, and this is going to be stored in X, right? And then I'm going to add X to sum, and once I'm done with the loop, I'm going to print the sum, right? So if I want to write this in C, here we're initializing sum, but in fact in Python this is not necessary because all variables in Python are applied to 0 by default. If I want to do this in C, first rule is I cannot really use X or sum or any variable without definition or declaration. So I need to define them. So I need to define sum and X to be integers, but I also need to define my variable that I'm going to use inside the for loop, my count, right? So I have 3 integer values here. And then I need to initialize my variables, and this is a very important rule in C. Make sure you always initialize your variables to some value, right? If I don't do this, values will get whatever garbage value is in the memory, and this is like the actual name of something in the memory that is not defined, it's called garbage. And then it's going to cause you a problem, right? So it's not a metaphoric name, it's in fact a scientific computer science name. Values in memories that are not really allocated are called garbage, and there is a huge research field in computer science, for example, it's called garbage collectors. One of the problems in C, for example, it doesn't have an automatic memory garbage collector, which means later on when we learn about memory allocation, if you don't do it yourself, your program will leak and you might crash your system. Right? Anyway, so the rule is always initialize your variables, otherwise you don't know what value they will get. And we might try this together right now. If I don't initialize sum and try to printf what variable it get. But then after initializing it, I want to write my loop. Another rule we said yesterday is that in Python, indentation is what defines your blocks, right? So if you look here, for example, I have a for loop. I have the 2 columns, and then once I do the tabbing, everything is within the block of the for, right? The last sentence, which is print, is not part of the for loop. The only reason is the indentation, right? In C, that's not the case. And in fact, it's more explicit, which I see better visible. Blocks are defined by curly brackets. So if you want anything inside the loop, it must be inside these brackets. Otherwise, it's not part of it, right? So it's not dependent on how you what is your writing style, spaces or indentation or tabs. It's more like with an explicit definition of a code block. And then loops, although in C++ we have something similar to this range thing, in C we don't have this. Every for loop would really be, in general, consists of multiple, 3 statements in general. The first one is your initial condition. The second one is your exit condition. And the third one is your count value. Here, for example, I'm saying starting from I equals 0, stop when I is not less than 10, and then every time increment I by 1. Here is written plus plus, but basically it means I equal I plus 1, right? It's usually called the increment. And then inside the for loop, I want to tell the user, please input something. And then once this happens, I'm going to scan it. So we have seen this already before. It's not a problem. And then I'm going to store the value in X. What else should I do after I have the value of X? Well, what is the ultimate purpose of the program? Is you want to sum all the numbers, right? So you want to put X as part of the sum, which means increase your sum. And then at the end, you want to print your sum. So one question to you, why do I have this printf outside the loop? Like what happens if I just put it inside? Yeah. Every time, exactly. And then that means that some value is going to be changing, right? So the first time only X, and then X plus then UX, etc. So I'm going to have multiple lines equal to, 10 values exactly. And then I would have the end value. But if I want to print some only at the end, I would put it outside of the for loop. Good? Does this make sense? So let's see if we still have a couple of minutes to code them. We do, so that's good. So let's play around with this code together. One thing I would encourage you to do is, if you're able to come up with your own machine or laptop to the lecture, and then we try these examples together. It might just get your hands dirty on writing some C code, become more familiar with the overall mindset. The bigger data should be. So assume I didn't initialize some, so I'm just going to run some x and I, and then I will do my for loop. And simply say, well, print f input and end, and maybe with a new line, and then I will scan f. This is an integer, and then I will take this into x. Good. And then I will say sum equals sum plus x. For sake of different trials we're going to run, assume I'm going to have this as only 3 variables, just to make it easy for us to process it. Then at the end, I'm going to print f sum equals another placeholder, and then sum. So if I initialize sum to 0 here, and I run this program, hopefully I didn't do anything odd. Please input an integer, I'll input 1, 2, and then why check that? 3. The sum is 6, makes sense. 1, 2, 3, 6, right? So assume now I'm going to modify things a little bit. Well, you asked about the AND, so assume I don't pass the AND for the scanf. What's going to happen? Well, it complains. It tells you that the format this is expecting an argument of type n, but in fact, it's just getting a pointer type, so it's not going to work. In other words, well, this is a very complex message. You will learn more about it later on. But what it means is, well, I was expecting something to be bad for writing, and you're only passing it for reading, right? So I cannot do this. The second thing, okay, I cannot do this while it's running. Okay. The end. Assume now that I don't initialize sum, and I hope online GDB does not do something small. Let's say 1, 2, 3. Wow, what is the value we get? Something that's very big. Why that's the case? Because you're adding sum to itself plus x. The very initial value of sum, something that you didn't control, just comes from the memory. When, well, in coming week lecture, we'll learn really how variables are being defined. You get a place in the memory that's allocated to you, but it's not initialized. If you don't initialize it, it still holds the old value from another program, not our program, and then it's anything, right? But one question is, why do we care only about the sum? We didn't initialize x and I. And that's a bonus question. If someone answers this, there is one bonus. I usually do these things in lecture. There are bonus mark questions. And I ask someone if he answers like a bonus question or for a question that I say is a bonus mark, please send me your name by email. Well, this here, not me, send it to Shuru. Yeah.
I would zero initial for loop, and then you scan that, and you the value of x to.
Exactly. Thank you. Yeah. So that's a correct observation. So the general rule of what your friend said is x and y are being overwritten before they are used, right? So if I initialize them, the initial value is not used anyway, right? This is the rule. But for a good programming practice, initialize everything, right? So there is a good programming practice, and this is what actually the compiler is doing. A good programming practice is saying, well, initialize all your variables and don't really think even whether they are used first or not. Because in a very big project, Wow, in a very big project, it can be complex to identify though. But here it works for X and Y because they are being overwritten. X is being overwritten by the scanf and the I is being overwritten by the 0. So we only care about the sum. Why? Because we read the sum in this sentence before writing. Make sense? Good. So if that's the case, I would say let's stop here. We're already over time, and I will see you all on Tuesday. Thanks, everyone.